Welcome everyone, excited to see everybody here. Sorry it's a bit crowded, but we will figure it out depending upon how things turn out to make sure we have a room that can accommodate everyone. But excited to have you all here for this new class we're teaching at Harvard, using big data to solve economic and social problems. I'm Chetty. This is Greg Bruich, the head section leader. We're delighted to have Greg participating in this class, and he'll be managing a lot of what we're doing. So I'm going to start by just diving in and talking about a big picture concept that I think matters a great deal to America. It's central to the American identity, which is the concept of the American dream. American dream is a multifaceted thing that means different things to different people. But I think one central aspect of it that means a lot to people in America and immigrants to the United States like myself is the idea that America is a country where if you work hard, you'll have a chance of moving up in the income distribution relative to your parents. So anyone has kind of a shot of making it. And so I want to start out with this chart here, which is from a paper I wrote last year with my colleagues, which assesses the extent to which that's actually true in the United States today versus in the past. So are we actually living up to the ideal that America is a place where kids can rise up relative to their parents? So what we're doing in this chart is computing a very simple statistic. What fraction of kids go on to earn more than their parents did, measuring both the kids' incomes and their parents' incomes in their mid-30s. And we're computing that statistic by the year in which the child was born. So if you look at the far left here, we're looking at data for children born in the 1940s. And then we're looking at that data all the way up to children born in the 1980s, who are in their 30s today when we're measuring their incomes. And so what you can see here is that for kids born in the middle of the last century in America, it was a virtual guarantee that you were going to achieve the American dream in some sense of moving up. 92% of kids born in 1940 went on to earn more than their parents did. And if you look at what has happened over time, you see a dramatic fading of the American dream, such that for children who, in the current generation, children who are turning 30 today, entering the labor market at present, you see it's essentially a coin flip as to whether you're going to do better than your parents. 50-50 shot of earning more than your parents did. Now, this broad trend is of great interest to economists, of course, in understanding why has the economy changed so much such that America was a place where we expected one generation to be more prosperous than the previous in the past, but you know that's no longer the case. But I would argue it's also of great social and political interest. So if you look at the places, if you think back to the last presidential election, the places that voted for Trump, the places where you saw the most people expressing frustration that America is no longer a land of opportunity like it once was, many of those areas like Ohio and Michigan, places like that, you see the steepest declines in terms of this chance of rising up relative to your parents. And if you look at the public narrative and look at what people are talking about, you often see this frustration that America is not the country that it used to be, where through hard work you could come up. And so motivated by that broad trend, a very natural question of interest to social scientists, policymakers, and the general public is why is the American dream fading? It's a central policy question, not just in terms of understanding why children's chances of climbing the income ladder are falling, but also importantly, what can we do to reverse that trend, right? Ultimately, what types of policy solutions, what types of social changes might lead America to again be a place where people, especially from lower income or middle income backgrounds, have a chance of rising up. Now, I start with that question both because it's a topic we're going to spend a good deal of time on in the coming lectures in this class addressing directly, but also because it motivates more broadly what I want to do in this class and the genesis of teaching this course. So if you just think about answering that question, what you can see is that it's going to be very difficult to answer that question, why is the American dream fading and what can we do to reverse the trend, based solely on the historical data, the macroeconomic data that I've shown you. So if I just show you those 40 or so data points that I plotted on the previous slide, you get a sense of what the trends are at a national level, but it's going to be very difficult to figure out just using that information what is driving that trend. What's the kind of conceptual scientific problem? It's that there are numerous things that have changed over the past 50 years in America. from changes in technology to globalization to changes in tax rates, education policies. And when you've got so many different things going on and you have a very, very limited number of data points, you're going to have a really hard time figuring out cause and effect and figuring out what the mechanisms are that matter for making policy changes. So until recently, social scientists have basically been in this position of having pretty limited data to study big picture policy questions like the one that I started out with here. So as a result, social science has primarily been a theoretical field. So if you take a traditional economics curriculum, to some extent even at Harvard, but even present day at Harvard, certainly in the past, but typically in economics, you're going to focus on studying mathematical models of how the economy works, or if you take a different social science, like in sociology, for example, more qualitative approaches to understanding how society works, but all primarily rooted in theory. And the traditional approach was to use these theories to explain the patterns that we see and make policy recommendations, for instance, in this case, on how we might go about improving upward mobility. Our theories might tell us maybe it's about a change in tax rates or a change in education policies or whatever it might be, depending upon the theory that you write down. Now, the problem with that purely theoretical approach, in my view, is that when your theories are untested, you often end up in this situation that economists are frequently criticized for, where if you ask a group of economists a question, 5 economists will often give you 5 different answers on what you're supposed to do. And it's often a very contentious field where it's unclear, exactly what the right answers are. And I think the unfortunate consequence of that is that it leads to a politicization of questions that in principle are fundamentally scientific questions that have scientific answers. So to take one example that's recently been in the news, a lot of debate about whether Obamacare is good or bad. Universal health care, is that good or bad for the economy? Is it reducing job growth in America, which is something that frequently came up in previous political campaigns. So if you think about that question, is Obamacare reducing job growth in America? While it's actually a topic of political debate, when you think about it, that question has a yes or no scientific answer, right? Either it is or it's not. We don't know what the answer is, which is why it ends up being a political issue. But if we had the right empirical tools and the data and the methods to actually answer that question, my sense is we'd all be much better off because we'd be able to make policy decisions that actually improve the economy and improve society rather than making choices based on political ideology. Of course, politics is always going to play a role, but injecting evidence into these debates can potentially move the ball forward quite a bit. And so, motivated by that background, there's, I think, the most important trend in social science today, economics and other related fields, is that we're becoming a much more empirical field thanks fundamentally to the growing availability of data. We can test and improve the theories that we've developed in the past using real-world data, and we can take an approach that's more analogous to the natural sciences, where we're running experiments or quasi-experiments to figure out what works and make decisions on the basis of data rather than speculation. So just to put some data behind that very claim that our field is becoming more empirical, this chart here shows you the percentage of articles published in leading economics academic journals that are data-based, that are empirical. And so you can see that in 1983, that was only something like 1/3 of the articles that were published. It was mostly a theoretical field. Then you can see how that's changed dramatically over time. With now, what people are talking about is much more based on data. And my sense is that's accelerated even further in the past 7 years after these data were constructed. Now, the recent availability of big data, the title of this class, has further accelerated that trend. And these large data sets, which is what we're mainly going to focus on in this class, have really started to transform social science just as they've transformed the private sector. So to give you some examples, we'll talk about in this class the use of data from the government, so information like tax records, health records from the Medicare system covering essentially the entire US population, huge samples of information that allow you to study things in ways that were unprecedented in the past. As another example, corporate data. So think about data from Google search queries or Uber on where people are driving or where people are asking for cars and so forth. Retailer data from, say, a grocery store scanning every product that people purchase. All of these data sets, as you'll see, are useful not just for these companies to improve their businesses, of course, but also for social and economic questions. And then a third category, unstructured data, what you might not typically think of numerical data to begin with. But think about things like Twitter feeds or newspapers. In a sense, those are sources of data, right? They're in the form of text, but there's a tremendous amount of information there. And a lot of recent exciting work in the field of machine learning has developed techniques to take that text and turn into quantifiable information that we can, again, use to study a very broad range of questions, such as people's emotions or how people feel about different issues, political trends, and so forth. Now, why is this sort of big data transforming social science? And why is it so important as a cornerstone, I think, for this field and more broadly, a lot of things that you all might do in your careers in the future? So traditionally, the approach to trying to collect information from people was to survey them and ask them questions, right? So there are lots of surveys in the US where we ask people, what's your income? What's your level of education? Things like that. And the problem with those surveys is that both they are very expensive to field, and as a result, they're quite small, but also they tend not to be very reliable. So if you think about, for instance, suppose I want to have data on what people are consuming. If I ask you, what did you buy over the past year in terms of food or other products, it's probably going to be pretty hard for you to provide an accurate recollection of your consumption patterns. In contrast, if I have information from your credit card, I can directly track consumption patterns in a much, much more precise way. So that's factor number one that makes these new data from administrative sources, where you're not asking people for the information, very valuable for the type of analysis we're going to talk about. Second, as I briefly mentioned before, there's an ability to measure new variables. So things that would be pretty hard to quantify, like people's emotions or political beliefs. If you ask people about those things directly, it's hard to elicit that in a very clear way. Whereas if you use information like Facebook likes, for example, gives you some proxy, some really scalable way to understand, how people feel about different things. Similarly with the Twitter feeds and so forth. Third, with the type of data we're talking about, you'll often have universal coverage. So you'll cover every person in the United States or all people in the population you're interested in. That's useful not just because it's really comprehensive, but also because you can zoom into very specific subgroups. So you will see in some of the work we'll talk about later this lecture, actually, that it's useful to zoom in to, say, Black men growing up in a certain neighborhood in one part of a city in the United States. There's no way you would have had the data to do that in the past, but you'll see why that's incredibly valuable, that you see such different patterns for different subgroups in understanding problems like the American dream. And then finally, because we have these really large samples, we can approximate scientific experiments really well. So traditionally, the major challenge in the social sciences is we can't run experiments like scientists can in their labs, right? So you're trying to figure out how different health insurance policies would affect the economy. Obviously, it's going to be very difficult to run a randomized experiment where you have one type of health insurance policy at random for this part of the room and a different type of health insurance policy for that part of the room. And so you've got to figure out how can you use the data you have on hand, what we call observational data, to essentially make comparisons and figure out cause and effect. And as I'll show you in this class, huge data sets can help us make progress on that front as well. Okay, so a bit more background before we start to get into this material. So why are we teaching this class and why are we taking this approach for the first time here at Harvard? So my view on this and how I started thinking about developing this class is that, of course, we all know that companies like Amazon or Google have succeeded in solving major private market problems using technology and big data. If you think about Amazon's model, it just fundamentally boils down to a huge logistics and economics problem that they've hired a lot of economists and computer scientists to help solve using massive amounts of data on what people want to buy and how you stock inventories and so forth. The goal of this class is to show that the same skill sets that are incredibly valuable in settings like Amazon can also be used to address important social problems. So think about pressing issues like growing inequality or climate change. I think the same types of skills that we're talking about in solving the private market issues using big data can be put to great use in tackling these challenges. And that's an area where I think we need a great deal more talent, and there's no better group of people than students at Harvard, I think, who can make a difference on these issues. So in order to achieve that goal, the idea of this class is to provide an introduction to a broad range of topics, methods, and real-world applications of these sorts of ideas. And fundamentally, the thought I had is that we want to start from the questions that motivate the methods we teach in economics and social science at Harvard, rather than the traditional approach, which is to do the reverse. So the canonical economics class, some of you might have taken, at least traditionally, would start from concepts like supply and demand, comparative advantage, supply and demand for widgets, like some abstract thing. And what I found is most students say, like, why do I care about the supply and demand for widgets? Like, what is this? Why should I be motivated to study this field? And so here what we're trying to do is kind of flip that on its head a little bit and start out with the questions that we think can be solved if you learn these tools, and use that as a way to show why you might want to take further courses in this area. We're not going to teach you every method and teach you all the different concepts in one class by any means, but unlike I think in the sciences where even in middle school and high school students get a sense of why it's exciting to learn biology or physics or chemistry and what applications that might have, I think in economics often I find if I'm at a party and people ask, what do you do? I say I'm an economist. The first thing they ask me is, can you tell me what's going to happen to the stock market? And I actually have no idea what's going to happen to the stock market. That's not what we work on. So trying to give the general public, and students here a better sense of what economists actually do is part of the purpose of this class. So what are the types of topics we will cover? Here's a quick overview. You can read in more detail on the syllabus what specifically we'll be covering on each of these issues. So first, we're going to spend a bunch of lectures talking about equality of opportunity, basically tackling the question that I started out with in the first slide. What's going on in terms of kids' chances of rising up and achieving the American dream? What are the drivers of that? What types of policies can we enact to restore the American dream to where it was 50 years ago? Second, closely related to that, it might not surprise you that education is going to be a key element of that. And so we'll talk in greater detail about the economics of education, touching on a variety of topics. So for instance, are charter schools better than public schools? Or how do we get the best teachers in our classrooms in America? What's the effect of having a great teacher when you're 5 years old on how much you earn or what college you go to? How can we ensure that kids from lower income families have access to higher quality education? Third, we'll talk about racial disparities. So you'll see later in this lecture and throughout this class that race plays an enormous role in thinking about a variety of issues in America, from inequality to education to opportunity. And so we'll have a series of lectures thinking about racial discrimination, how to measure it, why do opportunities and outcomes vary by race, and so forth. Fourth, we'll shift gears a little bit, turn away from economic outcomes. The first three segments will mainly be focused on things like income, employment, college attendance. We'll then turn to show how you can apply similar tools to think about issues of health. So we'll see, for instance, that life expectancy varies by 15 years between the poorest Americans and the richest Americans. The richest Americans live 15 years longer on average than the poorest Americans. Why is that? And what can we do to close that gap? And what are the effects of things like health insurance or changes in diet or other types of things you might consider? Next, we'll turn to issues of criminal justice. And there I'm going to specifically focus on tools from the machine learning literature, where there's some really interesting new stuff contrasting the effects, contrasting the decisions that a judge would make with the decisions a computer would make given all the data that's available, and trying to use that to assess when judges might be making mistakes, when there are biases in the judicial process, and so forth. We'll then turn to a very different set of topics, tax policy. So all of these things you might recognize, are connected to things that you're reading about in the news. So in the case of tax policy, many of you might have read recently, for instance, Alexandria Ocasio-Cortez talking about a 70% tax rate on very high income earners. So is that a good idea? Is that not a good idea? What's the effect of having very high taxes? How should we think about how we should set tax rates in the American economy? What effects will that have on economic growth, on inequality? It's the type of questions we'll talk about in that part. We'll then turn again to a very different topic, climate change. So what are the drivers, more of a scientific question, what are the drivers of climate change? But then the social science question is, how do we adapt in response to climate change? What are the downstream economic impacts going to be? And what types of policies can you use to change behavior? That's where the social science comes in. If we want people to consume less electricity or use cleaner sources of energy, what types of policies can you enact that will achieve that goal? And then finally, most of what we'll talk about in this class, given the nature of it, big data, we tend to have that in developed countries and advanced economies. At the end of the class, we'll talk about how you can use similar methods in developing countries to think about issues like extreme poverty with new technology like mobile phones and other new data. Think about issues of institutional change and how all of this translates beyond places like America. Now, in the context of those topics, so as I said, we're going to take a topic-oriented focus in this class. It's not going to be, we want you to learn this method and that method and so forth, but we're going to introduce a bunch of methods that will be useful for studying these topics, as well as we think a variety of other things that you might do in the future at Harvard or down the road in whatever careers you seek to pursue. So I'm going to just give you some quick examples here. By no means should you understand all of the words on the slide, but basically the hope is by the end of this class, you'll have some sense of what these various concepts are. So we'll start with just basic methods of descriptive data analysis. We'll get into a little bit of that today, in fact. And so that's topics like correlation, regression. Later on in the class, we'll talk about something called survival analysis, looking at data over time. We'll then talk about experimental methods, so the basic idea of randomization, what's called non-compliance in the medical literature, where people don't do exactly what you intend in the experiment. How do you deal with that problem? We'll then talk about quasi-experimental methodologies. How do we approximate experiments when we can't actually run experiments directly, which is typically the case? Methods like regression discontinuity, difference in differences. We'll then talk about machine learning methods, so things like prediction, overfitting a model, cross-validation, all techniques that are kind of bread and butter in that literature now. And then along the way, you will pick up some statistical programming language in the context of the empirical projects you'll do in this class. Stata is typically the software that economists use. You're welcome to use other software languages, but we want you to be conversant at a simple level, and we will teach tools even for people who have never done any programming or any statistical analysis. You'll be able to pick that up in this class. Now, when we're talking about these statistical methods, it's useful to distinguish between two different types of big data. So in this the title of the class, I use the term big data. Big data is kind of a buzzword that everybody likes to talk about, especially in Silicon Valley. But what does it actually mean? So I find it useful to classify big data into two different types. So the first is what you might think of as a long data set. A data set where there are many observations, say about lots of different people, relative to the number of variables that you have. So think about, for example, US income tax records, which our research team works with quite a bit. So in the income tax data, you have one tax return, you have information from tax returns for every person in America. So call that about 350 million people. You have that information over the past 20, 30 years. So you're talking about a data set that is something like 7 billion rows long. It's a very long data set. Obviously not a data set you'd open in like an Excel spreadsheet. It's got a lot of information. And so just to give you a sense of what that structure looks like, you could imagine you have information on all these different people, how much they're earning, how many years of education they have, did they go to college, did they not, et cetera, their gender, and so forth. So this is a typical structure of a long data set that people often work with in social science. In contrast, often what people in the private sector mean when they talk about big data is what I would call a wide data set, where there are very few observations relative to the number of variables you have. So if you think about Amazon's data set, for instance, you're trying to predict what products somebody will be interested in buying based on what they've clicked on in the past. So what does that data set look like? you might have a large number of customers. Just to make the point, I'm imagining, I have data here on 10 people, but then I have a ton of information in some sense about each person, where I know whether they've clicked on the first ad I showed them, the second ad I showed them, all the different products they've searched for, so forth and so on. So I have a tremendous amount of information about every single person. So this data set is wider than it is long. So why is that distinction useful? So statistics and computer science, some of you might be taking big data classes in those fields. They typically focus on these wide data sets. And the main application that they focus on is prediction. So I want to predict, say, what your income is in order to target the right ads to you. If I can figure out, based on all the products you've bought in the past, that you're likely to be interested in luxury goods, that's super useful, because as a company trying to sell something, I don't want to waste my time showing ads for like a Mercedes-Benz to somebody who's not going to be interested in buying that, right? That is a pure prediction problem. I don't care about cause and effect. I just want to predict what your behavior might be. And if I have a tremendous amount of information about you, you can use modern, what are called machine learning methods to make those predictions. That is very different from what social science has traditionally focused on, which are these long data sets, like the tax records. And why have social scientists typically focused on these long data sets? Because mostly we're interested in identifying causal effects. We don't just want to predict what's going to happen. We want to be able to change what's going to happen, right? We want to know if we change policies in the economy, change the way the school system is set up, or change the way we finance schools in America, what will happen to the amount of education people get or the quality of education. That's not just a prediction problem. We actually want to understand causal mechanisms. And so this distinction, we'll talk about both types of data in this class. We'll talk about both prediction and causal inference, but that distinction is quite useful to keep in mind as we think about what we mean by big data. Okay, so I've talked a little bit about the types of statistical methods we'll talk about. I want to briefly now discuss the economic methods that you will learn in this class. So we will learn about things like the effects of price incentives. So when I change prices, how does that affect supply? How does that affect demand? So the basic concepts of supply and demand will come through in that context. We'll talk about the idea of equilibrium, which is fundamental in economics. So when you change something, it changes each individual person's behavior, but then we all interact in society, and that creates an economic equilibrium. And how does that emerge? We'll talk about that idea. We'll talk about cases where the economic equilibrium will break down, in particular a concept called adverse selection that creates issues with standard equilibrium. It's very relevant in health insurance markets. And then we'll also talk about a variety of other ideas. So I think one of the most exciting developments in the field of economics recently is behavioral economics. So abandoning the traditional assumption that sort of everybody's perfectly rational is kind of like a calculator that does everything perfectly, bringing in ideas from psychology and sociology and other fields to make the picture richer and show how we can actually model how humans behave rather than basically designing theories that better describe computers. So it gives you a sense of some of the types of economics you'll learn in this class. Now, with that general overview of the content, I just want to say a couple of quick words about the logistics and the structure of this class. So we recognize, some of you might be thinking as I was going through that material, that not everyone taking this class has the same background in statistics and economics. So for some of you, the stuff that I was describing on the previous few slides, you might have already seen all of that before. You were familiar with those terms. For others, it might be the first class you're taking of this type. So that's totally fine. The lectures will be structured so that everyone can follow them regardless of your background. And hopefully, regardless of your background, you'll find the material interesting and engaging. You'll be learning something new. The sections are where we'll try to address the fact that people are coming in with different backgrounds. We'll have two types of sections based on whether you have prior coursework in statistics or econometrics. And so we have a fantastic group of a dozen teaching fellows who are going to help us do this. We'll send out some emails this week asking you about your prior coursework and your preference, basically to take a section that assumes prior knowledge or a section that assumes no prior knowledge. And accordingly, we think everybody will be able to learn the material in this class at whatever pace is suitable for you. And we're happy to talk afterward if you have questions about exactly how that will work. To help everyone learn, we'll have a series of empirical projects that we will assign. So think of these like problem sets, but kind of broader than that, where we'll focus on real world questions, and they'll involve a bit of coding, reading papers, writing. So giving you a flavor of what the research process looks like, basically, what your professors at Harvard are typically doing, what the graduate students are doing. So to give you one example, the fourth project will be analogous to the Netflix challenge that some of you might have heard about, where Netflix had this prize for people to develop machine learning algorithms to predict which movies people would want to watch. And so we will analogously have a social mobility challenge to identify the predictors of social mobility, upward mobility, like what I was showing you at the beginning, and neighborhood change, and have you develop your own algorithms to do that, and obviously support you in figuring out how to implement that. Now, the Netflix challenge, the winner of that got a $1 million prize. I don't think we can give you that here, but hopefully you'll find the experience rewarding. In addition to that, we will also have, excited to have 5 excellent guest speakers who will come join us here to talk about how they're using these types of data and these methods in real world applications. So Sean Donovan was a cabinet member in the Obama administration. He ran the Housing and Urban Development Agency and the Office of Management and Budget. And Sean is going to come and talk with us about affordable housing and how some of the research we're going to talk about in this class is directly influencing what HUD is doing at present to help low-income families access better neighborhoods. Tim Rennick from Georgia State has developed really innovative methods to help kids complete college and achieve better outcomes in college using big data. Jesse Shapiro will talk about food stamps programs. Lynn Overman will talk about how they're using big data in the Middlesex County Sheriff's Office to improve decisions in the criminal justice system. And then Esther Duflo, who's one of the leading scholars of this generation on poverty in developing countries, will come over from MIT to give a guest lecture on those issues. Now, one thing I should note is all of these folks, as you can imagine, are in incredible demand, and they're doing us a huge favor by showing up and coming to talk with us. And so we want to make sure we give them a good audience and lots of people who are excited to learn from them. And so attendance at the guest lectures is going to be mandatory, and we're going to take attendance specifically at the guest lectures just to make sure we have a good turnout when these folks come to visit us. So one final bit on the course logistics. I'm not going to go through it in detail here. You can look for yourself on the syllabus about grading, dates of assignments, reading list, course policies. If you have questions, please contact Greg. We do ask students to attend all lectures, again, kind of taking this empirical approach. Research shows that learning is most effective in person. You might think, oh, I'll catch up on the readings or look at the slides or whatever. We will post the slides before each lecture. Even this lecture slides are available on the web already, so you can take notes easily. But I strongly encourage you, and we really ask that you come to all the lectures. The lecture's intended to be interactive, so nobody's asked a question yet, but please feel free to ask questions at any time. If you have a question, it's very likely one of your classmates has the same question. It makes it more interesting for everyone, so please just put up your hand, feel free to interrupt. And if you miss a lecture for a documentable reason, we are recording the lectures. We're not planning to post those on the web, but email Greg, and if you've got a reason for missing the lecture, we're happy to give that to you. So any questions before I go on? Yeah, please.
Will the people in an advanced section be graded more harshly than people in a
So it's a good question. We're trying to figure that out. I mean, I think it's not that people are going to be penalized. I mean, we don't want to penalize you for knowing more coming in. At the same time, we want to have a reasonably level playing field. So there's going to be a common exam that everybody's going to take. Going to be empirical projects that everyone does. So it's not going to be some sort of relative grading like that. But we're going to try to provide support basically for folks who have not been exposed to these materials in the past, so that they quickly catch up to the others for the purposes of this class. Any other questions? Yeah, please.
Can you explain again why data sets are better for private sector as well?
Yeah.
In social problems versus long ones?
Yeah. So the question was, can I explain again why the wide data sets are more suitable to private sector applications and the long data sets are more suitable to social science applications. So it's a good question. I want to be clear, first of all, that it's not like some hard and fast rule that all wide data sets are always used in the private sector versus the others. So there's a bit of, change in using more wide data sets, more prediction problems in the social sciences and so forth, which I'll talk about here. Maybe the better way to phrase it would have been that social scientists tend to be interested in causal effects, and folks in the private sector are to some extent interested in causal effects, but are especially now often interested in prediction. So that's, I think, the core distinction. Are you trying to predict what will happen, or are you trying to change what will happen? So if you think about, take another example from the private sector. So in Wall Street, tremendous interest in using big data in the context of finance to predict what stock prices are going to be, right? So the idea here is not that you're going to use that information to directly change what's going to happen in the stock market. You want to just be able to predict. If I tell you, I have no idea why the stock price of Amazon is going to go up, next year by some amount, but I can tell you that it is going to go up. That's super useful information if you're a trader on Wall Street. And so when you're interested in prediction, if you just think about what type of information is going to be useful for you, you're going to want to use all the variables you can possibly get to make as good of a predictive model as possible, right? Now, suppose in contrast, I want to understand the mechanism that is leading something to happen. So why is it that children's chances of climbing the income ladder are falling? There, the idea is not that I want to have 1,000 different variables to predict what's going on there. I want to have a handful of things that I might actually be able to change, that I can then, education levels, et cetera, that I can then go study one by one. And so then if you just think about it from that framework, I'm going to tend to want to have a lot of data on a lot of different people, hence a long data set to study the causal question. And if I just want to do a prediction, I want to have a lot of information per person, hence a wide data set. So that's sort of the logic. Other questions? Yeah. Speak up, yeah. 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 Excellent question. So if you define the American dream as moving up relative to your parents, one simple intuition is that how could that keep happening generation after generation? Like eventually, aren't you going to run out of room to move up relative to your parents? So we're going to talk about that particular slide and the underlying analysis in much more detail in a subsequent lecture. Let me give you a quick answer here. So the basic reason you can keep moving up is that we're talking about moving up in absolute dollar terms, right? Are you earning more just in absolute dollars relative to your parents, adjusting for inflation? And how is it the case that we're able to keep moving up generation after generation? It's because we have economic growth, right? So total GDP, the size of the economic pie, is much bigger now than it was 30 years ago. And so we'll talk about in a later lecture how if we divided the pie today the way that we were dividing it 30 years ago, that is if we had less inequality basically, we would see rates of upward mobility today that look much more similar to what we had in the past. So the fundamental reason, there's no deep reason you kind of have to stop at some point because you continue to have economic growth in most modern economies. If you at some point stopped having economic growth, then your intuition would be right that there's only a limit to how much you can move up relative to your parents. Yeah. Anybody else? Yeah. Yeah, space permitting, so well, yes, but feel free to come, yes. Great, okay, so I'm now gonna get into the material for the first lecture, starting with the equality of opportunity topic. Okay, so we're gonna divide this into two parts. First, we'll talk about just geographical variation in upward mobility in America. So I started out with that national chart. What I want to show you as a way to kind of get more data points or to start to understand the problem is that the story of the American dream varies greatly across different parts of the United States. It's not like a single thing for the entire country. There's a lot of geographical variation across places. Then in the second part, so that's going to be basically a descriptive analysis from a methodological point of view. In the second part, I'm then going to tackle the question of whether those differences we're going to see across places are due to the causal effects of place. That is it the consequence of growing up in different neighborhoods that you have a different shot of achieving the American dream? Or is it what social scientists call sorting? The types of people who live in some parts of America are different from the types of people who live in other parts of America. So this first lecture is based primarily on the following paper, which is on your syllabus, which is a recent paper we put out just a couple of months ago called the Opportunity Atlas. Okay, so let's start with the first part on geographical variation in upward mobility. So the question we want to ask in this first section here is, how do children's chances of moving up vary across areas in America? So think about it in a very simple way. Suppose I'm a kid growing up in a low-income family, say a family earning $25,000 a year. That puts you at roughly the 25th percentile of the income distribution. Are there some areas of America where I'm more likely to rise up and have a higher level of earnings in adulthood than others? And if so, what lessons might we be able to learn from the places where we have high levels of upward mobility? Basically, you can see that this is an effort to split up the data and create more data points. The way we learn in social science is fundamentally by examining variation across different units, and in this case, across different places. And so the first thing we're going to do is just ask, use big data to measure how upward mobility varies based on where kids grow up. So before I get into the analysis that we've done to examine that question, it's always nice to see what people's guesses are, what people think are the places with the highest levels of upward mobility in the United States. And so we're going to do the following thing, and Greg, help us if this doesn't work. So take your phone or your computer, go to this URL, pollev.com, Act 1152, and click on the state that you think has the highest level of upward mobility. By that I mean, imagine you're a low-income kid in a low-income family growing up in that state. Where do you think you have the best shot of reaching the middle class or beyond? And so let's see what people in this classroom think before I show you what the data show. Give you a minute. Not a lot of love for the Midwest, I see. Wow. It is true that outside America. All right. We call it? All right. Okay, so let's turn to see what the data actually show in a minute. Just to summarize the patterns, I guess 3 people or a handful of people think upward mobility is higher outside of America than actually. That is actually correct, which we'll. And then seems like tremendous amount of support for California in the Northeast, Texas. It's interesting, and then not very much in the center of the country. Okay, so keep that in mind. I will show you what the data look like in a couple of minutes after describing how we answer this question empirically. Okay, so how are we actually going to measure upward mobility by state, by geographic area in the United States? All right, so here's how this works in this Opportunity Atlas paper. So we start from census data. So you all know the US Census has been in the news lately because of all the controversy about collecting information about citizenship. So US Census is supposed to cover the entire US population. It's conducted every 10 years. So we take that data, 2000 and 2010 census, and we link that to information from federal income tax returns. Essentially, everybody in America files a tax return every year, right? And we have that tax return data from 1989 to 2015. So when you link those data sets, you basically have information on every American between 1989 and 2015. How much are they earning? Where do they live? Lots of other information like that, the dependents they have, things like that, year by year. Okay, so that's the raw data set we're starting from. It's this giant anonymized data set, as I was describing before, that's something like 8 billion rows long. Okay. In that data set, we want to study economic opportunity across generations, right? So the key with all of these big data sets is you never have the data set structured for your research analysis to begin with, because that's not the purpose for which it was collected. Obviously, tax returns were collected to administer the tax system. The census data was collected for other purposes, districting and so forth. And so you need to think about ways that you can make use of that data to study the question at hand. So in this particular case, it's extremely important to be able to link kids to their parents to study economic opportunity and mobility across generations, right? And so some of you might know that when your parents claim you as a dependent on their tax return, which gets you basically a deduction, you save money on your taxes, they have to write down your social security number so that the IRS can be sure that you're not just making up kids in order to save money on your taxes, right? And so then there's like a internal validation system to make sure that the SSN you wrote down corresponds to a real person under the age of 18, and to make sure the same kid doesn't get claimed multiple times and so forth. And so we are able to use that information to link 99% of kids in America back to their parents, thereby giving you this intergenerational sample where you can study income inequality and mobility across generations. So what we're seeking to do in this analysis is examine all kids in America born between 1978 and 1983. Why those particular years? Because we need you to be old enough such that we can measure your earnings reliably. So if you were born in 1995, in 2015, you're going to be only 20 years old. We can't look at your earnings, right? You're going to be in college. Some people will be working at that point, but obviously your earnings when you're 20 or 25 might still be in grad school, med school, whatever. It's not going to be a reliable measure of how well you're sort of doing in the long run. And so we found that you need to wait till people are basically in their 30s for this to work. And so that's why we focus on that set of years. And we're interested in people who were born in the US or are authorized immigrants who came to the US in childhood. Why authorized immigrants? Because these data sets don't do a great job of covering undocumented immigrants, so we're basically not going to try to study that population here. So where that leaves us, when we take our big 8 billion row data set and then focus on the sample of interest, is a sample of 20.5 million children who represent 96% of the set of people who we think we should be finding. Why is it not 100%? Because there's some kids who you can't link to their parents. There are some people you can't link the census form to the tax form. So there's like a little bit of slippage when you do this kind of stuff. But 96% is pretty good. You have virtually everybody you're trying to study. Okay, so we take that data and we measure people's incomes. So how do we measure their incomes? We just basically take it off of your tax returns. So for parents, we're going to take your average income reported on Form 1040, the main tax return in the US, average between 1994 and 2000. Similarly for kids, we're going to measure your average income in 2014, 2015, the last 2 years of the data we were working with. So that's when kids are in their mid-30s. In everything we do, we're going to focus on what we call percentile ranks in the national distribution. So what that means concretely is that we're going to rank kids relative to all the other kids born in the same year and parents relative to all other parents. So let me just make this super concrete. Take all the kids born in America in 1980. There are about 3.5 million of them. We see their incomes in 2015, order those from 1 to 3.5 million. Just literally sort the data based on how much you're earning as reported in the tax records. The first guy at the very top is ranked first, and then all the way down to 3.5 million, right? And we convert that to percentiles, and those are what I call the percentile ranks. So we're comparing kids to other kids of the same age. And then likewise, we compare parents to other parents. Why do we do it that way? Because we want to adjust for the fact that as people grow older, their incomes tend to rise. So you don't want to just compare kids to parents, because all the kids on average, because we're measuring their income at younger ages, they're going to look like they're lower income than the parents. That's why we compare kids to other kids who were born in the same year to create these rankings, okay? So this chart here shows you the first look at the data at the national level. And so what we're doing here is on the horizontal axis, the x-axis, we're showing you the parent rank in the national income distribution. So there are 100 dots here, one corresponding to each percentile of the distribution. And then in each of those 100 bins, we're plotting the average ranking of the child in the national income distribution. So this first dot here, for instance, says, if you were born to parents in the bottom 1%, the very lowest income families in America, on average, those kids, when we look at them when they're about 35 years old, they are at the 30th percentile. Okay, so they've moved up on average relative to their parents. Now, as you go to the right, you're looking at kids from richer and richer families, and you see that there's a very strong upward sloping pattern. So this reflects the simple fact that if you were born to a richer family in America, you yourself tend to be richer in adulthood. So the kids born to parents at the top of the distribution, on average, they're ending up around the 70th percentile. The kids born to parents at the bottom of the distribution are ending up below the 30th percentile. So this reflects what we call intergenerational persistence, that is, advantages in one generation tend to be transmitted to the next generation. So this is the data, so this data is for kids who were raised in the Chicago metro area, okay? So we took all the kids raised in Chicago and kind of surrounding suburbs, and we constructed this plot here. Now, what we're gonna do is do a similar analysis in every part of America, and then put it on a map similar to what you guys just filled out to measure upward mobility. Now, in order to measure upward mobility, what we're going to do is fit a line to these data. So when you look at this chart, you can see that it looks pretty linear, meaning that it's well approximated by a straight line. And so given that, we're just going to compute a best fit line using a method called regression that some of you will have seen. Others will talk about in section how exactly you run a regression to find the best fit line, okay? But for now, just think of it as I'm going to find the line that fits that data most accurately in some sense. And then I'm going to focus on the value of this line called the predicted value at the 25th percentile of the parent income distribution. So why am I doing this? I've got 100 different values for each place, right? And I want to be able to basically construct a digestible single statistic to kind of summarize what does upward mobility look like for kids growing up in Chicago versus Minneapolis versus Florida or whatever. And so the way I'm going to do that is fit this regression line and take the predicted value of that line for kids growing up in families at the 25th percentile. So think of that as low income families, like below average income, right? And so what is that predicted value given parents at the 25th percentile? Just read that off from the y-axis. That's the 40th percentile, right? So in Chicago, on average, kids who start out in families at the 25th percentile end up at the 40th percentile. What is that, just to give you a sense of the magnitude? That corresponds to having an earnings of about $30,000 a year when you're in your mid-30s. So kids growing up in low-income families in Chicago, roughly speaking, earn about $30,000 on average when they're adults. So you might wonder when you look at this chart, why am I going through all this trouble of fitting this regression line and then finding the point that's on that regression line and so forth to compute rates of upward mobility? You might think instead, like, why didn't you just directly use what the value of the dot was at the 25th percentile? Why do you need to bother with this statistical model, the regression and so forth? So here's another example. Rather than looking at Chicago as a whole, let's imagine we look at one small neighborhood within Chicago. I'm going to show you in a second how we're able to zoom in with these data, not just to the state level or the city level, but specific neighborhoods within each city. Now, what's going to happen when you zoom in really close is you have a smaller sample of people, right, within each area. And so the data is going to look a lot more noisy. There's going to be a lot more variation. Just by random chance, the kids who grew up in this neighborhood at the 25th percentile didn't do so well, but then the kids who grew up at the 26th percentile, they're a different set of households, they ended up doing quite well, right? It's just going to be random variation across different kids is going to produce this kind of bouncing. And so in this case, it starts to become very important to fit that regression line. In other words, to use the discipline of a statistical model. That's kind of the core idea of statistical models, to take the underlying data and represent it in a way that is more stable, basically. And so in this case, do the same exercise, you get a predicted value at the 25th percentile of, again, the 40th percentile in this example. But if I were to just use the dot at the 25th percentile directly, I would have concluded that that number is like 31 instead of 40. But clearly, that's a bit of an outlier relative to the broader trend, right? So the line is giving you a better guess, probably, of what would happen on average in that place. And so what we do is basically fit a line like this to the kids who grew up in every different census tract in America. So census tract is a small definition of a neighborhood that the Census Bureau has created. There's 70,000 census tracts in America, each of which has about 4,200 people. So to give you a sense of scale, Cambridge itself gets divided into 32 different census tracts, and then we take the kids who grew up in each of those 32 different places within Cambridge and fit a best fit line to the data like what I just showed you here. Now, one last thing before I show you what you actually get. In practice, you might be thinking, okay, you're saying where kids grow up, but some of you might have moved while you were kids, right? Like, what does that mean, where you grew up? And so what we're doing here is weighting children by the fraction of their childhood that they spent in each area. So to make it concrete, suppose you spent half of your childhood growing up in Cambridge and half of your childhood growing up someplace, say, in New York. You're going to count as 50% of a person in Cambridge and 50% of a person in New York. And similarly, because we're able to see where everybody lives year after year, we allocate you in proportion to the amount of time you spent growing up in each of these different areas when we fit these models. Okay, so that's the technique, that's the methodology. What do you get from it? This is the map corresponding to what you all, to the poll you all filled out. So the way this works is we're showing the average household income for kids who grew up in low-income families, where blue colors depict areas with high levels of upward mobility. So start by just looking at the scale here. In the dark blue colors, kids starting out in families at the 25th percentile, families earning $27,000 a year, they are on average earning more than $45,000 a year when they're adults. So they've moved up quite a bit relative to their parents on average. In the red colors, they're below 27,000. Okay, so they have made no progress across generations. In fact, many of them might have gone backwards on average. So you can see the broad geographic variation for yourself. Relating it back to the poll, I think you were right that the coasts look pretty good in terms of upward mobility. What I think often people are surprised by, consistent with the polling responses, is that actually the highest upward mobility areas in America are the Great Plains, the rural parts of the country in the center of the country. And that may be surprising because you don't think of that necessarily as like a hub of economic activity. But that, I think, is one of the most interesting features of this map. Some of you might be from places like Atlanta or Charlotte, where you might know that those cities are often viewed as the fastest growing cities in America. Charlotte is one of the cities in America with the highest rates of job growth in the United States. Yet, somehow remarkably, for low-income kids who grow up in Charlotte, your prospects really don't look very good. You don't have very good chances of moving up. And so that's the power of this type of data, that you can start to understand that there's a tremendous amount of variation in kids' chances of moving up depending upon where they're growing up. That initial chart that I showed you, even in the current generation, while on average kids' chances of moving up relative to their parents don't look that great, there are some parts of America where they still look fantastic, actually better than any other country in the world. And then there's some places like down here or much of the industrial Midwest, places like Cleveland and so forth, where your odds of climbing up look worse than any country for which we currently have data. So America is a land of tremendous variability and opportunity. Question?
I'm a little confused why we're combining percentile and
Yeah.
monetary income. Isn't the broad growth would change which income would
Yeah.
which percentile growth?
Yeah, good question. So so let me give two answers to that. So the reason we're doing that is when you're looking at one point in time, there's going to kind of be a one-to-one correspondence between the percentiles and the monetary values. So when you're comparing over time, then that distinction is going to matter, right? But if I'm looking at, this is just a snapshot of the current generation, basically is the way to think about it. Now, a different way to ask your question is, why do you bother going through the percentiles? Why don't you just show in that scatter plot that I was showing you? Why don't you just do that in dollars to begin with? The reason it's very useful to transform it to percentiles is basically a statistical reason that if you did it in dollars, that relationship is very far from linear. It's super curved, so when you get to higher income levels because of outliers, the means will get pulled up a lot, and so it becomes much harder to fit that systematically with a statistical model. It works much better if you do it with percentiles. So it's basically a statistical simplification, but then we bring it back to dollars because it's more intuitive for people, right, than to say 43rd percentile here, 37th percentile there. It gives you a bit more of a concrete feel for it. Yeah?
So we think that in general, society, that college makes you richer in the long run. And you count up to your age of 23, whether or not you're that.
Can you speak up a bit? Yeah.
Sorry. You
Yeah.
count up to 23, right? Whether or not you're counted as part of that city. So did you see higher correlation with more concentration of colleges in a certain area where higher growth?
Yeah. Yeah, so these are excellent questions. So, is this associated with having a higher concentration of colleges or colleges of certain types and so forth? So this is exactly what we're going to talk about, trying to unpack this map to understand what might be driving the variation. I don't think it's just about the concentration of colleges, but I will come back to that in more detail. Let me take this down here and I'll come up there. Yeah.
How does this take into account the different cost of living in different geographic regions?
Yeah.
If I start out in the 25th percentile in a high place with a very high cost of living like the Bay Area, and then I move to a place with a lower cost of living, if my income goes down, what are the odds that my quality of life still goes down because everyone's a lot cheaper?
Yeah. Good question. So this map is just nominal incomes, meaning it does not adjust for differences in cost of living. Is $40,000 worth the same in one place versus another? How would these results change if you adjust for cost of living? So let me give you two answers to that. The first is an empirical answer. So you can redraw this map adjusting for differences in cost of living. You can basically measure kids' incomes and parents' incomes, adjusting for the fact that New York is much more expensive than another place, basically using what we call a price deflator, right? So we know what average rents are, the average cost of buying groceries is, and things like that, and you basically divide by that number so that in New York you're pulling down people's incomes, and in Iowa you'd be pushing up people's incomes to adjust for those differences in cost of living. When you do that, you get a map that looks almost identical to the one that I'm showing you here. To put it more precisely, the correlation between that data and these data is 0.9, meaning that it looks essentially the same. And so then, why is that the case? Why is it the case that it actually doesn't matter that much if you adjust for cost of living? The reason is actually the example you gave of somebody moving to a very different place is typically an anomaly in the US, especially for kids in lower income families. So most kids who grow up in low income families tend to live around the areas in which they grew up, even in adulthood. I think statistic I remember is the average kid lives 17 miles from their mom when they're 30 years old or something like that. So most people, this is an unusual group of people, obviously, but the typical people, the average person in the United States tends to stay close to where they grew up. So why does that matter for the question you asked? Think about a place like New York. So upward mobility is fundamentally about the difference between the kid's income and the parent's income. So in New York, the parents are going to look poorer and the kids are going to look poorer. And as a result, the statistic is actually not going to change that much. Another question?
So this map reflects the lowest quartile. How much does it change if you're looking at middle class income?
Yeah. So we're focusing specifically here on kids growing up in low-income families. If you look at kids growing up in middle-class families, it's broadly similar. Where it looks really different is if you look at kids growing up in very high-income families. So what you find there is that there's just significantly less variation across areas. So to take a concrete example, if you're growing up in a family at the very top of the income distribution, if you grow up in Atlanta or Charlotte or New York or San Francisco, you have very similar outcomes. It doesn't seem to matter a whole lot where you live if you're rich, which I think kind of makes sense intuitively because you can insulate yourself from the local institutions. So some of this variation, as we'll talk about, is driven by access to local public schools or factors like segregation. If you just think about it intuitively, if you're from a very high income family in Atlanta, even if the local public schools are not great, you can send your kid to a private school, right? And so that's the nature of the variation you see across the income distribution. Anyone else? Yeah, in the very back.
How confident can we be in our data being accurate in the methodology used? For example, the weighting of the
Yeah.
percent of the time is great.
Yep.
How do we know that that's the correct way of
Yeah. Yeah, and so the question, how do we know that this method produces the right estimates? So a lot of the time, the time that social scientists spend, a lot of what we do is develop a result like this, but then evaluate the sensitivity or robustness of that result to lots of variants of that method. So in this particular case, I might not weight you by the amount of time you spent in each area. I just use where you were born or where you lived right before you went to college. I can do it in lots of different ways, right? Or I can adjust for cost of living. So we construct many variants of this. And so if you guys look at the paper on which this is based, you'll see that there are lots of different, basically, versions of this. And we try to extract the lessons that seem to be most stable and representative. And my general sense is, in this particular case, this turns out to be a very robust pattern. The details of the methodology don't matter. But obviously, it's very important to do that type of analysis. Yeah. Yeah.
You know what's happening with those two counties in South Dakota?
Yeah, right up here? Yeah, actually, so does anyone have a guess? Yeah.
Indian reservation?
Yeah, those are two of the biggest Native American reservations in the United States. And so that shows you the power of the data, right? That it picks up something that people have known anecdotally for a long time, that there's chronic intergenerational persistence of poverty on reservations, and you see that that's getting captured very accurately here. Okay, so in this big map, your eye focuses on this relatively broad regional variation, right? The Northeast looks better, the industrial Midwest doesn't look so great, and so forth. What I want to do in the last couple of minutes is show you that this is not just about broad regional variation, but it's actually about extremely local variation. So I'm going to toggle over to this tool, the Opportunity Atlas, which you can access yourself by just going to opportunityatlas.org. This is an interactive tool that we developed and released a couple of months ago to visualize these data. And we're starting out with just the national map that we were looking at before, the same statistics that we were looking at before. But what I'm going to do now is zoom in to areas of specific interest. And so what I'm going to do is take one particular example. So let's go to Nickerson Gardens. You can type in any address you want in this tool. And so I'm going to zoom into central LA, basically. So central LA. Some of you have probably heard of Watts and Compton, very famous areas being kind of tough places to grow up, high crime, high poverty, see it in the movies and things like that. Okay, so first thing that I want to point out is I've zoomed into LA. I'm looking at the data census tract by census tract. Notice that the range of colors that you see in this map is the same as what you were seeing at the national level. So in other words, you can be in the middle of LA and drive 4 miles over, and it's like going from Alabama to Iowa in terms of rates of upward mobility. So this variation is not just at different regions of the United States. It's actually hyper-local. And this is true not just in LA, this is true in cities across America, that here in Boston or wherever you grow up, you can go type in your home address. You will see that outcomes vary dramatically across places. Now, just to give you a flavor of the magnitudes here, I'm going to focus on one subgroup that illustrates some of the patterns that we'll spend quite a bit of time on in this class. So let's look at black men growing up in the lowest income families in this public housing project in Watts called Nickerson Gardens. So lowest income, by that I mean the bottom 1% of the income distribution, which is actually representative of the incomes of the families living in this public housing project. So we're looking at that dot here. You can see it's in a dark red color. Look at this statistic. The average household income of black men who grew up in the poorest families in Watts is just $3,300 a year. So how does that happen? How do you have an average income of $3,300 a year? It has to be the case that lots of people are basically not working at all, right? They have zero income. And that's how you end up with such a low mean. And you can see that in a very direct way in these data because we're able to look not just at income, but a variety of other outcomes. And so I'm going to click over here now to incarceration rates. And you see, I think, a really shocking and disturbing statistic about the United States in this area in particular, which is that 44% of the black men who grew up in these lowest income families are incarcerated on a single day, the date of the 2010 census. So, if you think about what are your lifetime odds of being incarcerated, given that 44% on a single day are incarcerated, it's going to be something like 70% of those kids end up incarcerated at some point. And so from that perspective, you can see why this is a place of tremendous disadvantage, why these kids have average incomes of only $3,300 in adulthood. Now, if you're from LA, at some level you might be shocked by the magnitudes, but qualitatively you might think, yeah, I knew Watts was a really tough neighborhood, really adverse outcomes. But here's something that might have been less obvious to you. So if you go down here to Compton, look at some of these areas down here, you see incarceration rates, for example, in this tract that I'm hovering over, of 6.7%. So, factor of 10 smaller than the 44% that we were seeing in Watts for black men growing up in low-income families. Now, Compton is a different neighborhood than Watts. It's not exactly the same, but I don't think anybody from LA would think of Compton as like some fantastic, super high-income place. And so, what that shows you is you can go 2 miles away and just have a dramatically different picture in terms of what kids' life trajectories look like. And so we see that, in the Stark example here within Los Angeles, but, we see that sort of thing more broadly across the United States. And so what we'll talk about in the next lecture is what is driving this extremely sharp variation across places and start moving towards how can we change things so that we give kids growing up in Watts and other areas in the red colors on the map better chances of climbing up. Thanks, everyone.